Taking the derivative of trigonometric functions follow a specific pattern similar with the other transcendental functions. Learn about them here in differential calculus. From trigonometry, we learned that there are 6 functions and our goal for the course is to take the derivative of each. Let's start. The derivative of sine x is cosine x times dx all over dx, or that is the cosine of the angle times the derivative of the angle. The derivative of cosine x is sine x, and this is with a negative sign. The derivative of tangent x is secant squared x, and the derivative of cotangent x is negative cosecant squared of x. There is also the derivative of secant x, which is secant x tangent x. Then, the derivative of cosecant x is negative cosecant x cotangent x. In order to master these patterns easily, first, observe that the negative derivatives appear with the co-trigo functions. Those are cosine, cotangent, and cosecant. Next, the patterns come by pairs. The first pair are simply opposite of each other. The second pair is the pair of squares, secant squared and cosecant squared. The third pair is the double trigo. They are secant tangent and cosecant cotangent. Let's apply the patterns in some equations. First is with the function w is equal to cosine of 4t. From the pattern, the derivative of cosine x is negative sine of x. So if we start with the differentiation, we take 4t as x. Then w prime is negative sine of 4t times the derivative of 4t. That can be taken as 4 times the derivative of dt all over dt, which is reduced to 1. Thus, the derivative of w is negative 4 sine of 4 times t. Example 2 is with the function z is equal to secant of half of y. From the pattern, we have the derivative of secant x as secant x times tangent x dx all over dx. So start with differentiation by focusing on x as half of y. So, z prime is secant of half of y tangent half of y times the derivative of half of y with dy all over dy, again taken as 1. Thus, z prime is half of secant y halves times tangent y all over 2. Example 3 has the function a is equal to 6 times secant of 3b. The derivative of secant x is secant x tangent x. With differentiation, we take x as 3b. So a prime is the constant 6 times secant of 3b times tangent of 3b with the derivative of 3b. This can be simplified as 3 times db all over db, which is taken as 1. So we end up with 3 times 6 of secant 3b times tangent 3b, which results as 18 secant 3b times tangent of 3b. The next function to derive is c is equal to tangent of the quantity a quarter of pi less half of g. This time, the trigo function involved is the derivative of tangent x, which is taken as secant squared of the angle. So in differentiation, we take x as the quantity of the quarter of pi less half of g. The derivative of c is then taken as secant squared of the quantity times the derivative of that quantity, where the derivative of 1/4 of pi is 0, as it is taken as a constant. So the shortened equation is then secant squared of the quantity times half of dg all over dg, which is 1. So the final C prime is half of secant squared of the quantity pi all over 4 minus half of g. Example 5 has the equation u is equal to sine squared of 3t. Take note that due to the exponent 2, we have a prior step before the trigonometric differentiation. We use power rule where the derivative of u raised to n is n times u raised to n minus 1 multiplied by du all over dx. With the function, we mark sine of 3t as u. So u prime is written as the exponent 2 times the term sine of 3t raised to 2 minus 1. Then, this is multiplied by the derivative of u, which is sine of 3t. Next is the derivative of sine 3t, which then can be solved from the pattern cosine x times dx all over dx. So the resulting u prime has x as 3t. U prime is 2 sine 3t cosine 3t times the derivative of 3t, which is similar with 3 times dt all over dt, which is again taken as 1. So the final u prime is 6 sine 3t cosine of 3t. The next example involves the equation s is equal to t squared times cosine squared of 3t. This time, there are two terms in the function, t squared and cosine squared of 3t. Having two terms multiplied in the function, we start with the product rule, having the pattern u dv plus v du. S prime is then taken as the first term t squared times the derivative of cosine squared 3t plus the second term cosine squared 3t times the derivative of t squared. Note that the derivatives are now focused on smaller parts of the function, and they both employ the power rule. Now s prime has t squared times 2 cosine of 3t times the derivative of cosine 3t plus cosine squared of 3t times 2t times dt all over dt, which is reduced to 1. At this point, the only derivative remaining is that from the first term, and it involves a trigonometric function. So we get s prime as 2t squared times cosine 3t times negative sine of 3t with the derivative of 3t plus cosine squared of 3t times 2t. We can simplify the terms where the last derivative has 3 times dt all over dt. Finally, s prime is negative 6 t squared cosine of 3t sine of 3t plus 2t multiplied by cosine squared of 3t. The last example has the equation w is equal to secant of 2v plus tangent of 2v. Although we have two terms, they can be differentiated separately with secant and tangent. So w prime is secant 2v tangent 2v times the derivative of 2v plus secant squared of 2v times the derivative of 2v, and both are simplified as 2 times dv all over dv. So the final w prime is 2 secant 2v times tangent 2v plus 2 secant squared of 2v.